Hi everyone, here's another video on finding the domain of a function that's represented by a formula. And I want to do a pair of examples in this video. So I would like to look at a function here. Let's see, write down directions. We're going to find the domain. First function, we'll call it d of x, is equal to x plus 1 over x squared plus 3x plus 2. Okay, so basically when we're finding the domain of something, there's not a lot that can get us in trouble right now. We're going to run into new functions as we go in this class and into pre-calc 2 as well. But right now, the only things we have that can give us trouble are fractions and even roots, square roots, fourth roots, sixth roots. We cannot have 0 in the bottom of fractions, and we cannot take the even root of a negative number. So those are the two things we want to check for. When I look at this function, I see that it is in fact a fraction, so I will have to worry about the division by 0. There are no radicals, so I'm not worried about negative numbers. I don't have a problem putting a negative number in the top or the bottom of a fraction. The only thing I have a problem with fractions is if I have 0 in the denominator. So basically, I want to make sure that the bottom of this thing does not equal 0. For a lot of these, the easy way to do this is just going to be to factor the bottom. So if we go ahead and factor x squared, we're going to split up into an x and an x. 2, we don't really have a lot to choose from. I get a 2 and a 1, and they can either be both positive or both negative. If I want my inside-outside to add up to 3x, I'm thinking both positive looks pretty promising. So here's my x squared. There's a 1x plus 2x. There's the 3x in the middle. And a 2. That looks perfect. Okay, so if you get the denominator in factored form, it just gives you a little bit of a shortcut. Basically what we're saying here, and you don't even have to write this out for me if you understand what you're looking for and you can just spot it. We want to make sure that x plus 2 times x plus 1 does not equal 0. That's what we're checking for the domain. The bottom of a fraction should not equal 0. Because this is in factored form, it's really easy to spot what would make it 0. If we don't want that product to equal 0, we need to make sure that x plus 2 doesn't equal 0, which means x can't equal negative 2. And we also want to make sure that x plus 1 doesn't equal 0, which means that x can't equal negative 1. So if we want to be a little more formal about it, basically we can plug in anything we want other than negative 2 and negative 1, and this really is an and in the middle, because we want to make sure that both of these are true at the same time. It's not good enough for x just to be not negative 2. It also has to be not equal to negative 1. If you have any confusion about the and or, feel free to just stick with some interval notation. We want to include everything from negative infinity all the way up to negative 2. We do not want to include negative 2, so we're going to do some round brackets here. And we're going to start back up from negative 2 and include everything until we get to negative 1. This is important. Again, remember that variables don't only take on integer values. So we don't want to skip everything between negative 2 and negative 1, because negative 1.5 and negative 1.9 and negative 1.1 are all perfectly valid inputs for this function d. And then final step here, we want everything from negative 1 up to positive infinity. So it's a little longer to write out, but if you're confused about the and or part, it might be a little safer for you to just write it this way. Okay, so I want to move on, but I'm actually still going to come back to this one. The next problem is related. The next function is related. Let's see if I can find a color here. Excuse me. E of x. Let's say E of x is equal to 1 over x plus 2. And I would like to find the domain of this function. So this is looking like actually a fairly easy problem. There are no roots, so I'm not worried about negative numbers, but there is a fraction, so I'm worried about the bottom of the fraction being 0. So I'm going to say I want to make sure that x plus 2 is not equal to 0, which means that x cannot equal negative 2. And that's really it. And I'm done, and you're probably wondering why this is interesting at all in relation to the last problem, and I'm getting there. If you like your interval notation, this would be negative infinity to negative 2, combined with the interval from negative 2 to positive infinity. So either one of these is great. Okay, so how does this relate to the last problem? If you were paying attention up above, you might have spotted that the top and the bottom share a common factor. So according to algebra, I should be able to cross this out and say, oh, this is equal to 1 over x plus 2, which is exactly what we were just working on. Except that I have to be a little more careful. This is a big part of what pre-calc is about, is getting a little smarter with our algebra. So that's a completely valid step, but you need to recognize that when you cancel something, you can lose track of a domain restriction. When I'm looking at the first or the second function, I can very clearly tell if I try and plug in a -1 that that's trouble. All of a sudden, from here to here, I can't tell that plugging in -1 gives me trouble. So I guess I want to ask a really specific question here. And the question is, are d of x and e of x equivalent functions? And I'm going to ask you this in your homework, and I will very clearly restate in your homework what it means to be equivalent. Let me just say it right now. Two functions are equivalent if they're algebraically the same. You can simplify one algebraically and turn it into the other formula. And if they also share the same domain. So a function and its domain are inseparable. Even if two functions are algebraically the same thing, algebraically equivalent, if their domains are different, they aren't actually quite the same function. So that's what I want to look at really carefully here, and this is just thinking about domain. So again, this is just being really careful with our algebra. Yes, algebra says you can cancel out the x plus 1, and you will get 1 over x plus 2, except that these two do not match up if you try to plug in a -1. If you plug in any other value, they'll match up. If you plug in 0, you're going to get a 1 on top and a 1 in the bottom. That wipes out, and all you're left with is a 1 over 2. If you plug in 3, you're going to get a 4 on top, 4 in the bottom that'll cancel out. All you're left with is a 1 over 3 plus 2, 1/5. But if you plug in -1, you're going to get 0 over 0, which is still undefined. 0 over 0 does not cancel out. So the truth is, I can only claim that these two are equal if I keep track of the fact that x is not supposed to equal -1. So this is supposed to be a comma, this funny looking thing. So yes, x plus 1 over x plus 2 times x plus 1 is equal to 1 over x plus 2 for any x except for -1. So the answer to the question here is no, they're not equivalent. They are algebraically the same. I can reduce function d, I end up with function e, but their domains are very slightly different. If we were talking about graphs, which we will do at the end of the quarter, graphs of rational functions, really what's happening here is that the graphs of the two are identical, and if you graph them on your calculator, that's all you'll see, except for one thing that the calculator doesn't show you. Function d has a tiny little hole in the graph, so I know what these look like. This is using advanced knowledge. We'll learn this at the end of the quarter. Function e, let me think about this. Okay, so it looks something like this. This is what function e looks like. The only difference in function d is that at -1, there's a hole in the graph, one little open circle sitting there, and your calculator won't show you those. You have to be able to find them. So we'll work on that at the end of the quarter. But just to have an idea in your head of what this means about graphs, means the two have the exact same graph, except function d has a hole at -1 and function e does not. All right, thanks for watching.